tool can allow you to do that. But let me just quickly go through one more. All right. Now, about facade. All right. Now, for facades, you know, the very first pictures that I show you, all right. Okay, now, I think probably you guys also need to so-called look into that. When you first design a building, okay, energy consumption, energy loading, okay, all right, the heat loads, the cooling loads that you need, all right, to cool this space. How are you going to address this? All right, so I hope you guys can actually look into the use of ETTV for your design. ETTV, please, okay? All right. So ETTV will allow you to come up with an estimation about the amount of energy that you need to cool that space. Okay? All right. So now the thing is this. For building like this, okay, it's not easy. Simply, it's not easy. So in other words, all right, but you guys have to look into that. Huh? I'm just so-called, you know, give you some heads up. Okay, so and that is also could be one of the reasons why Singapore buildings cannot look as elegant as those buildings like the very first slide that I showed you, because of this building code, right? Because most of buildings cannot meet the ETTV requirement on time. Okay, all right. So things like that, this kind of building, okay. All right, Singapore, you're not allowed to that. Okay, this is going to be quite difficult for you to calculate ETTV. So I highlighted this before. All right, this is very simple building, but I talked to one very experienced M&E engineers, actually he's a director. He said, wow, you know, took him at least 6 months to just calculate these kind of things, just for the ETTV of this facade. Okay, so it's not that easy. All right. Now this baby, what is this? Jewel. Okay, all right. Maybe you guys should look at a survey. What is the ETTV of this building? All right, and then you know, do a judgment on that one. Okay, this is a very nice building. RTTV, ETTV. Okay, so for those of you who really want to look into that, all right, this is the ETTV, and the publication is all listed there, all right, since 1979 until, you know, recently, most of the equations are still remain the same. Okay, all right. So it's either you calculate by hand or you can calculate by so-called simulation. So this is one of the requirements, because you know it's a prerequisite for green mark, all right, to obtain the gold and platinum. So if you can calculate ETTV for your design competition, then probably you can get more points. Okay, for sure. Okay, please remember, include that, all right, into your calculation. Okay, and if you can't, okay, you do simulation, you get even more points. Okay, the software that you can use for calculating ETV, all right, besides BIM Track 2, you can do IES, you know, VS as well, all right, or maybe talk to your course instructor and see whether you can actually get a spreadsheet from one of the established consultant like Sabana Jurong. All right, see whether they want to share that with you or not. Okay, all right, the chances is no. Okay, all right, because there's a top secret. All right, so simulation, you can get more points. So look into that. All right, so this will impress your judge, the judges. Okay, if you can come up with energy estimation of your building. All right, so let me see. Okay, all right, this is a formula. So why this is important? Okay, because during your design of your building, just now Owen also mentioned that the first thing that you have to do is do a passive design, right? What does it mean? Passive design, that means you have to make use of shielding device, all right, to lower down the heat, so-called convections or conduction to the building. Okay, so passive design is linked to ETTV. Okay, now for building that you are that are very fanciful. Let me show you. Yeah. Okay. Hey, busy. Okay. Now, you pay attention to the some of the building that right now under construction, or maybe those are net zero building. All right. They are going to use this kind of screen, sun screen. Okay, some shading. Okay. All right. So maybe this is a hint, huh? To cut down your energy consumptions, maybe you can actually include this kind of shading device onto your facade. Remember just now one of the case studies presented by Owen, the NTU, the Green Tech building one. All right, Green Tech one. He said that he actually so-called include the envelope, right? So actually is this technology. All right, you put in a so-called a perforated screen in front of the facade, you cut down your ETTV. Now, let me ask you this. What sort of building is this? What sort of building is this? Mosque, right? So mosque, all right. One of the requirement is, nowadays the mosques are all air conditioned already. Okay, all right. In the past, it's naturally ventilated. So with air conditioned in place. All right, the building, all right, if they want to clear BCA to get green mark, okay, all right, they need to submit ETTV calculation. So this is going to be a big challenge, all right, for a lot of people, because it's a non-conventional shading device. Okay, so how? All right, okay. So a mosque, let me give you more information about the building design. All right, it's a very nice design. It's energy efficient. All right. So now the mosque come with this kind of facades. Okay. All right. How are you going to compute ETTV? Okay. All right. The air conditioned room is behind. Okay. All right. So some path analysis comes in. Okay, site analysis comes in. You need to do orientation. Then after that, right, if you need to do airflow simulation, you do airflow simulation. But if you can so-called compute ETTV, all right, then the judge will be very compressed. You can compute ETTV by hands for this building, let me know. I will hire you right away, okay? All right, so this is almost impossible to compute by hand. Okay, you need to have simulation tools because you need to do a ray tracing kind of activity, right? To quantify the net shadow coefficient. Okay, because the perforated screen will cast a lot of shadow. It's just like the Changi Jewel, the project, right? There are a lot of shadows. Okay, all right. So you need to do that. Okay, so what is the moral story? Get prepared. Prepare, all right? All right, you must know what exactly you want. All right, so I have highlighted a lot of simulation tools, a lot of so-called requirements. So maybe during your design, planning, a team, sit down for brainstorming. Start to think beyond just creating a 3D model. All right, the judge will not be impressed by just creating a 3D model. Understand? All right. So, with that, I open the floor for any questions. All right? Any questions? Anything? No? Sorry? You can actually, arrange through SP, all right? Okay, but simulation like this, okay, all right, it requires some training. So it's not just one night, overnight that you can actually plug and play, okay? All right, because we're talking about high level kind of activity here. All right, so you have to start early. Even for the simplest shadow, some path analysis, okay, you need at least 1 or 2 days training. For CFD, you need at least a month. Understand? All right? So be prepared. So if your project, if you need to submit your submission in July, you should start, learning the software, getting the team ready, start the 3D model, so on and so forth. Okay? Don't wait until last minute. This is not for fun. All right, this is a serious work. Okay? Simulation. Yes? Sorry? Will there be any tutorial? You are from SP, right? Can you arrange with June, your lecturer? Okay? Right. You know Chris, right? Just now, the lecturer that go out? No? Don't know. Chris Ho. You don't know. All right. So, any other questions? If not, I thank you so much for your attention for 1.5 hours. I know there are a lot of information shared. Okay? So, hopefully, I have excited you guys, all right, to go beyond just a 3D model, okay? All right? You need to use your skill set. You need to think how you present your case. You need to think how you beat the other competitor, okay? All right, through simulation, through calculation, through idea, okay? All right? Okay, thank you so much. Okay, bye-bye.